A new study, published in Astrobiology, suggests that organic molecules discovered in the Gale crater by the Curiosity rover are so abundant that conventional chemical explanations simply fail to justify them. If you like science and space exploration, don't forget to subscribe and give like. Each discovery brings us closer to understanding the universe around us. The research, led by Alexander Pavlov of NASA's Goddard Space Flight Center, focused on the remains of long-chain alkanes found in the Cumberland Formation. On Earth, these molecules are fundamental parts for the construction of cell membranes. The presence of these molecules on Mars represents a prime enigma that scientists are trying to solve. Although the currently detected levels are discrete, Pavlov's team warns that the key is not in what we see today. The study reveals that these samples have been punished by cosmic radiation for 80 million years, a process that relentlessly destroys organic matter. This degradation further complicates the understanding of its origin. By mathematically reconstructing the degradation suffered, scientists came to an amazing conclusion. Originally, the concentration of these compounds must have ranged from 120 to 7,700 parts per million. To put this figure in perspective, it is an abundance thousands of times greater than any previous expectation for a planet that, until now, was considered geologically inert. This raises the question, where did so much organic material come from? This is where NASA runs out of simple answers. Researchers tested every not-alive source possible, refuting each of them. Cosmic dust and meteorites provide levels a million times lower. Likewise, processes in the ancient atmosphere fail to generate such accumulation, and chemical reactions in rocks do not reach the observed complexity. This leads scientists to question conventional explanations. Given the inability of conventional chemistry to explain these figures, the scale begins to tilt towards biological processes. The concentrations estimated on Mars coincide with records found in sediments of ancient terrestrial lakes. Despite the enthusiasm, researchers advocate prudence. They recognize that there might be some chemical process still unknown that explains this phenomenon. But it is becoming increasingly difficult to argue that Mars was always a barren desert.